One of the questions that I get asked the most is how to proceed with the problem, how to recognize how to solve the problems. Let's look at this ACT problem and see if we can find out some patterns so that we can recognize. So we are given f of x is x squared plus 3x and g of x is x plus 1. So we immediately recognize that there are two different functions that are given to us. And then they're asking us what is the f of g of x. So when you have something like f of g of x or g of f of x, that is a composite function. That's a nested function, a function within a function. So what the idea is to start with the inner function and go to the outer function. Okay, so that is the recognition we have to do here. So f of g of x or g of f of x is what's called a composite function or a nested function. You can also see this sign sometimes, this big circle here, and these are all categorized as composite functions. What that means is you're going to start with the inner function, okay, and then you're going to go to the outer function. So whatever's inside next to the x here, that is what we're going to start with. In this case is g of x, so that is the inner function, and then the f is the outer function. So it's a function within a function. So let's go ahead and start here in the inner function, then we'll go to the outer function. So what is the inner function of g of x? So we're going to start with g of x equals x plus 1, and we know f of x is equal to x squared plus 3x. So we're going to start from the inside, and then what we need to recognize here is this is going to be our x value now to substitute into this f of x. Okay, so all of that inner function is going to be the input into the outer function. All right, so to substitute into the outer function, let's go ahead and do that. So wherever we see the x, we're going to put x plus 1. So x plus 1 whole squared plus 3 times x plus 1. So that is the thing we have to remember here and recognize that this is going to be the entire inner function is going to be substituted. So x plus 1 whole squared plus 3 times x plus 1. Now we're going to go ahead and solve that, okay, to get to our final answers, to simplify. So x plus 1 whole squared is x squared plus 2x plus 1. That's a perfect square trinomial. Or you can just write x plus 1 times x plus 1. That would be x squared plus x plus 1. That's x squared plus 2x plus 1. And then here we have 3. This gets distributed 3x plus 3. So then we are going to combine the like terms. So what are the like terms here? The like terms here are 2x and 3x. So x squared plus 5x plus 3 plus 1 is 4. So now we have combined the like terms, and this is our final simplified version, which is choice A. So what did we do here? We started with the inner function and then we went to the outer function. If we were asked the opposite, we would have started with the f of x and then gone into the g of x, substituted into the outer function, which was g. But we are being asked, so it's very important to see the sequence that we are being asked this question of the composite function. So just quickly, let's take a look what would happen if it were we would get a completely different answer. So we see if we are asked g of f of x, we're going to start with f of x and then substitute the f of x, which is 3x squared plus 3x, into this g of x, which is this here. So x squared plus 3x plus 1, you get a completely different answer. Okay, let me know if you have any questions. I'll talk next. Have a nice day. Bye.